In the last video, section 5.1, we looked at how to graph quadratic equations or quadratic functions in standard form. So finding the vertex, finding the roots, the x-intercepts, and finding the y-intercept. And then we used some concepts of symmetry to find points that were necessary to graph if we didn't have any roots, or if the roots were irrational. Now we're going to look at something called vertex form, and this is technically in chapter 3, but really it applies to what we're doing right now. Vertex form is if you take the standard form, which we were just talking about, standard form, and you manipulate it a little bit. And I'm gonna have something pop up on the screen here. You do not need to write this down when I'm about to pop up on the screen. It's going to look really complicated. I'm just going to kind of talk about it, and then I'm going to simplify it a lot. So if you take this standard form and you complete the square, so remember completing the square was you subtract c from both sides, you add something that makes this a perfect square trinomial, and then you add the same thing to the other side and work at it from there. It looks like this. Again, don't let this mess you up. You are not going to have to work with this equation at all, probably ever. But I want to make clear where some of this stuff is coming from. So if you completed the square with the standard form and you left a, b, and c alone, and you got y by itself again, it would look like this. The big thing that the two big things I guess I need you to take away from this is that this mess over here on the right side in the parentheses here is just one big number. There's no variable at all in here. This is c minus b squared over 4 times a. This is just a number. It's a really complicated looking number, but it's just one number. There's no variable involved here. So this is just a number. And this right here, next to the x inside these parentheses, so x is the variable, this b over 2a, that should look familiar. B over 2a, that is the formula we used to find the x portion of the vertex. So we wanted to figure out horizontally, back and forth on the x-axis, where the vertex was going to end up. We did opposite of b over 2a. So this b over 2a right here is coming up again. So this is where that b over 2a came from, is when we completed the square. So I'm going to, and this is just a number, b divided by 2, we worked with that already. That's just a number. So we've got one number here. We've got one number here. A is a number, and then square root of squared x is x. So I'm just going to rewrite this exact same thing, except I'm going to write it with a single variable to represent this number and a single variable to represent this number. It would look like this. So I just took b over 2a and called it h, because really that's the horizontal. That's where it moves back and forth on the x-axis, the vertex. And then this I just called k, which doesn't stand for anything but k. This is vertex form. This is what vertex form looks like. This you should write down. So you don't need to know anything more about this middle equation. This right here is the vertex form of a quadratic equation. And the way we're going to use this is if an equation is in vertex form, then it's going to allow us to kind of move our parabola, our U-shape, around the graph to certain spots. I'm going to show you how that works. But again, this h here, this number h inside the parentheses next to x, is the horizontal shift. It tells us where that vertex is going to move left and right along the x-axis. So it's grouped in here with x. And it's that x portion. K is the vertical shift. That's going to tell us how much up and down we go. So if we want to find the vertex, if we want to identify where will the lowest or the highest point of that U shape or N shape end up on the graph, if it's in this vertex form, these two numbers are going to tell us the x portion of that point and the y portion right away. Now you'll notice it says negative h here, or this is really the opposite of h. And that's because of right here. This is plus b over 2a. And the x portion of our vertex was the opposite of b over 2a. So that's why this negative h comes up And I'm going to keep talking about this opposite of h and how that plays into things. One letter I haven't mentioned yet is this A. I'm going to come back to this. That's the scale factor and reflection. I'll address that in a little bit. I'm going to concentrate right now on the horizontal and the vertical shift. So let's look at some examples, and I'll kind of show you how this plays out. So we have our most basic parabola, y equals x squared, and it looks like this. So the vertex is at 0, 0. 1 squared is 1, 2 squared is 4, 3 squared is 6. You get the idea. Or 3 squared is 9. Sorry, 3 squared is 9. So this is what's called the parent function. This is the most basic parabola you could have. All the other parabolas are some variation on this parent function. So let's look at a variation. Here is a slightly different quadratic function. It's similar. We had an x squared. We have a x plus 3 squared now, and I added a 1. So this is in that vertex form. What the vertex form told us is that the number in here with x, that's grouped in here with x, tells us the horizontal change. So 3 is the horizontal change, and this plus 1 tells us the vertical change. Now the vertical change was fine. That was just, going back here, k was just k. So the y portion of my vertex is just whatever this number is. Which means that the y portion of my vertex is going to be at 1. The horizontal, the x portion of that vertex, is going to be at the opposite of h. So instead of being at positive 3, it's going to be at negative 3. So what this tells us is that we're going to shift our parabola to negative 3, positive 1. And this is going to be our parabola. So if we want to graph this parabola, the vertex is going to be at negative 3, positive 1. And again, it's negative 3, not positive 3, even though it says plus 3, because of this opposite of h, this opposite of b over 2a business that we used before. And that's going to be very consistent. So we moved to the left 3 and up 1. In fact, this is going to be true for most functions, where if it says, and that's why I have an f here instead of the squared. Most functions, if you add h to x, if you add some number to x, you're moving that function h units to the left. Even though it's plus h, you're moving it to the left. And if it's minus h, you're moving it to the right. And so it's the opposite of what you would think. This is going to come up in circles. If you're moving circles around on a graph, it goes the opposite. If it's plus, you move it to the left. If it's minus, you move it to the right. It works for ellipses, hyperbolas. If you don't know what that is, don't worry about it. It's going to work for absolute value functions. If we were going to move absolute value functions around on the graph, it works the same way. And so this plus h and minus h is going to move it to the opposite of what you would think. Plus h moves it to the left, minus h moves it to the right. Okay, I think I've hammered that enough. The A, I told you I'd come back to that letter A, the scale factor and reflection. So I'll pause it if you need to write all this down. I'm just going to say it, but pause it and take the time you need to write it down. This tells us really how much we are stretching and compressing that U. We're making it a tighter U, almost to a V shape, like if you really shrink it in, or we're making it a really, really, really flat U. And so if A is bigger than 1, and we have these absolute values here because it could be a negative, but if A is bigger than 1, it's going to be stretched vertically. It's going to look like a really skinny U. If A is some decimal, so if A is between 0 and 1 or some fraction, it's going to be compressed vertically. And what that means when we say compressed is we're making it into a really flat U. And so it's going to be really kind of elongated, and it's going to be a really flat. You can't see my hands, but I'm actually using my hands to kind of like flatten out my hands. It's making a really flat U. If A is less than 1, if it's a negative number, so even if it's just a negative 1, if it's a negative number out here, it's going to reflect it and make it look like an N. And so a negative number out front here is going to make it look like an N shape. It's going to flip it around across the x-axis. If it's bigger than 1, it's going to stretch it and make it like a really skinny U shape. And if it's some fraction or decimal, it's going to be compressed vertically. So if it's between 0 and 1, it's going to be really flattened out U. All right, let's look at 2 examples. So I've got this equation here, y equals 4, and so we've got our scale factor. It's a positive, so it's still going to be a U, and it's going to be stretched vertically, a really skinny U. There you go, that sounds like a nice thing, right? A skinny U. So plus 8 means it's going to move it to the left 8, not to the right, and minus 3, we're going to move it down 3. So here's what it would look like without the scale factor. So I'm ignoring this 4 for now. We've got our parent function here. Here's that original parent function. The plus 8 is going to move it to the left 8. The minus 3 is going to move it down 3. So the vertex of that parabola went left 8, down 3. The scale factor of 4, I'm not going to ask you to graph a parabola with a scale factor. You're not going to be asked to decide how much do I shrink it or how much do I elongate it. But I want you to visually see what's going on. That's what it would be as a final result. So again, I'll go back. This was the just shifting it to the left 8 and down 3. That scale factor applied skinnied up that U. It made it a thinner U. Looking at another example, we got y equals negative a half, x plus 3 squared plus 8. That negative is going to flip my function around. It's going to flip it across the x-axis, and so it'll be more of an N shape. The plus 3 will move it to the left 3, and the plus 8 will move it up 8. So if the red line is my original parent function, that vertex was moved to the left 3 and up 8. The fact that it was a negative, it gives us that N shape. And then the half, because it's between 0 and 1 and not greater than 1, is going to make it a flatter U. And so when I talk about a flatter U, that's what I'm looking at. So I'll go back and forth here. So that was the original. And if you watch that blue line, it kind of stretches out. It compresses is what we would say. One thing I want to mention with the y-intercepts, we can still find the y-intercepts the same way we were doing before. You can still put 0 in for x and say, well, 0 plus 3 is 3, squared is 9, times negative a half would be negative 4.5, plus 8 would be 3.5. And sure enough, the y-intercept, 1, 2, 3.5. You could find the y-intercept here. Not going to show up on the graph, obviously, but 0 plus 8 is 8, squared is 64, times 4 is going to be, what, 256, minus 3 is 253, and so that's going to be way up there somewhere. But the y-intercept can still be found in the same way we were finding it before. Okay, so try 2 examples here. This is the last slide. Try 2 examples. Try and write the equation for a parabola whose vertex is at 4, negative 2, and is stretched vertically by a factor of 5. So while I may not ask you to physically draw a graph that has a scale factor of 5, I might ask you to write the equation that would give us this situation. So try and write that equation down in vertex form. For the second one here, I've given you an equation in standard form. I'd like you to try and find the roots, the y-intercept, and the vertex of that parabola. Pause it, try this on your own. I'm assuming you paused it. I'm assuming you tried it on your own. For the first one here, this would be our vertex form. Since the vertex is at a positive 4 and a negative 2, I put a minus 4 inside with the x here, and a minus 2 on the outside, because remember the h is the only one that's the opposite. The scale factor of 5 tells us we're multiplying that by 5. So there's our vertex form of this situation, of this parabola. Finding the roots, you could either use the quadratic formula or you could factor this. It factors nicely to x minus 3 and x minus 1. And so the roots would be at 3 or 1. So you would say the roots are at 3, 0, or 1, 0. I think I have listed at just x equals 3 and x equals 1. But it'd be at 3, 0, and 1, 0. The y-intercept, if you plug 0 in for x, you would end up with 0, 3 as the y-intercept. The vertex, if you took, again, opposite of b over 2a, if you took the opposite of negative 4, it'd be positive 4, over 2a would be 2, So there's our x portion of it. And if you plug 2 back in for x, you end up with -1 as the y value. So those are the types of questions that you might be asked, along with some graphing, especially of the standard form on a test, quiz, or an assignment.